Say goodbye to monotonous textbooks and hello to interconnecting colorful mind maps. Welcome to another discussion on our Mind Map series, where we help you quickly revise important points for your competitive exams. Let's begin this discussion on the topic of instrumentation and principles of cavity preparation. Instrumentation and cavity preparation is the backbone of operative dentistry. In this mind map, we will talk about the instrument formula, classification of hand instrument, steps in cavity preparation, and G.V. Black's classification of caries. Starting with the instrument formula given by G.V. Black. The instrument formula can be divided into the 3-number instrument formula and the 4-number instrument formula. Starting with the 3-number instrument formula here, the first number denotes the width of the blade in tenths of millimeter. The second number denotes the length of the blade in millimeters. The third number denotes the angle of the blade in relation to the shaft measured in hundredths of a circle, centigrades. For example, the formula 15, 8, 12 describes a hatchet with a blade width of 1.5 millimeters, a blade length of 8 millimeters, and a blade angle of 12 degrees. Coming to the 4-number instrument formula. The first number denotes the width of the blade in tenths of millimeters. The second number denotes the angle of the cutting edge to the shaft, measured in hundredths of a circle, centigrades. The third number denotes the length of the blade in millimeters, and the fourth number denotes the angle of the blade in relation to the shaft, measured in hundredths of a circle, which is centigrades. For example, the gingival marginal trimmer and the angle former have a 4-number formula. Moving on to the classification of hand instruments. Instruments in operative dentistry are broadly classified into cutting and non-cutting instruments. Cutting instruments are those that are used to remove the tooth structure. For example, excavators, hoes, angle formers, spoons, and chisels. Chisels can be subdivided into straight, curved, or bi-angled depending on their angulation. Other cutting instruments include carvers, gingival marginal trimmers, enamel hatchets, knives, files, and scalers. Coming to the non-cutting instruments, these instruments are used to pack the restorative material into the tooth, such as condensers, and also those instruments which are used during initial examination, such as mouth mirrors and probes. Moving on to the burr blade design, there are certain definitions that we must know. Head. The head of a burr is the part that contains the cutting edges. The shape of the head varies depending on the type of burr, but it is typically cylindrical or conical. The number of cutting edges on the head also varies, but most burrs have between 6 and 40 cutting edges. Next, rake angle. Rake angle is the angle between the cutting edge of a burr and the direction of rotation. A positive rake angle means that the cutting edge is angled away from the direction of rotation, while a negative rake angle means that the cutting edge is angled towards the direction of rotation. A positive rake angle produces a smooth cutting action, while a negative rake angle produces a more aggressive cutting action. The significance of rake angle has been depicted in the given picture. Clearance angle is the angle between the cutting edge of a burr and the shank of the burr. The clearance angle ensures that the cutting edge does not contact the shank of the burr as it rotates, which would prevent the burr from cutting effectively. Concentricity runout is the amount of variation in the distance between the center of the burr and the center of the shank. Concentricity runout can cause vibration and chatter during use, which can damage the burr and the tooth. Certain modifications have been made to the conventional burr blade design. These include reduced number of crosscuts and extended head lengths. Let's take a look at what these terms mean. Reduced number of crosscuts refers to the number of cutting edges on a burr. Burrs with a reduced number of crosscuts are less aggressive than burrs with a high number of crosscuts. This makes them less likely to cause damage to the tooth, but they may also take longer to cut. Extended head lengths refer to the length of the head of a burr. Burrs with extended head lengths have a longer reach than burrs with shorter head lengths. This makes them easier to use in deep cavities or in areas that are difficult to access. Now that we have discussed on instruments and the burr design, let us move on to the principles of cavity preparation. There are 6 basic principles of cavity preparation: outline form and initial depth. The outline form is the shape of the cavity. It is designed to provide adequate space for the restoration and to ensure that the restoration is properly supported. The initial depth of the cavity is maintained at 0.2 to 0.8 mm pulpily into the dentine. There should also be a 0.5 mm gingival margin clearance from the adjacent tooth. Cusp capping can also be done at this stage. When there is less than half of the cusp involved, cusp capping is not required. Between half to two-thirds cusp involvement, cusp capping may or may not be done, but when there is greater than two-thirds cusp involvement, cusp capping is mandatory. Resistance form. Resistance form is defined as the shape and placement of the cavity walls that enable both the tooth and the restoration to withstand the masticatory forces delivered on the long axis of the tooth. The features of primary resistance form are relatively flat floors, box-shaped cavity, preservation of cusps and marginal ridges, rounded internal and external line angles, and cusp capping when indicated. The primary resistance form also determines the minimal thickness of the restorative materials used, which is 1.5 mm in case of amalgam, between 1 to 2 mm in the case of cast metal, and 2 mm in the case of porcelain. Primary retention form is the shape or form of the prepared cavity that resists displacement or removal of the restoration from tipping or lifting forces. Features include occlusally converging external wall, occlusal dovetail, retention grooves or coves, mechanical bond using acid etching and dentin bonding agents. Convenience form. It is defined as the shape or form of the cavity which allows adequate observation, accessibility, and ease of operation in restoring the cavity. These were the initial steps of cavity preparation. Moving on to the final steps of cavity preparation, we have removal of caries dentin. Infected dentin must always be removed, while affected dentin can be left behind in the cavity preparation, depending on the remaining dentinal thickness. One must be careful while distinguishing between the two. Pulp protection. 2 mm of dentin must always be present between the pulp and the restorative material. This is known as effective dentinal depth. Pulp protecting agents such as cavity varnishes, liners, and bases are applied at this step depending on the depth of the prepared cavity. Secondary resistance and retention features. These include additional resistance and retention features such as locks, pins, slots, coves, and skirts. Procedure for finishing the external walls. This includes maintaining the cavo surface angle at 90 degrees to produce maximal strength of both enamel as well as the restorative material. Cleaning, inspecting, and conditioning. This is the final step in cavity preparation, which includes cleaning the debris, inspecting the cavity to check the correct shape and form, and conditioning the external and internal walls. In the last section of our discussion on this mind map, we are going to talk about G.V. Black's classification of dental caries. It was developed by G.V. Black in the early 1900s and is still used today. The classification system consists of 6 classes. Class 1. Restorations on the occlusal surface of molars and premolars, the facial and lingual surfaces of the molars, and the lingual surfaces of the incisors. Class 2. Restorations on the proximal surfaces of posterior teeth, that is the molars and premolars. Class 3. Restorations on the proximal surfaces of anterior teeth, that is the incisors and canines, not involving the incisal edge. Class 4. Restoration on the proximal surfaces of anterior teeth involving the incisal edge. Class 5. Restoration on the gingival third of the facial and lingual surfaces of all teeth. In these cases, pulpal wall is absent and depth of the cavity is maintained at 0.75 to 1 mm into the gingival wall. Retention grooves are placed on the occlusal or gingival areas. Class 6. Restorations on the incisal edges of anterior teeth or the occlusal cusp heights of posterior teeth. With this, we have come to the end of our mind map discussion. Hope we could make this topic easier for you to understand. Thank you.